In this session, I'm going to talk about domain of a function. Before starting anything, I would like to show you some important things. Number one, so look at that. We use this parentheses, and for example, if I use 2, 5, so it means that 2 and 5 values are not included in this range. Say I can write down 3 and 4, and also the second one is, if I use this square bracket, it means that including these values also. So 2 and 5, this range includes this 2 and 5. Say for example, I can write down as 2, 3, 4, and 5, including 4 and 5. And number 3, this 1 divided by 0.0, 1 point, say like this. If I divide 1 divided by 0.1 is 10, and 1.1 divided by 0.01 is 100. How you get that? This denominator is 0.01. To remove the decimal, and then I have to multiply by 100. So when you multiply by 100, and then on the top also you need to multiply by 100. So denominator becomes 1 and the numerator becomes 100. Also the first example, 0.1, to remove the decimal, I have to multiply by 10. And the top also I have to multiply by 10. Then the bottom becomes 1 and then top becomes 10. So 10 divided by 1 is 10 and 100 divided by 1 is 100. Say similarly, say 1 divided by 0.001 means 1000. So 1 divided by 0.001 means 10,000. So look at this one, and when the bottom, say 0.00001 is becomes 100,000. So see this one. So when that the bottom becomes smaller, the top value, the answer would be the higher, right? It means that when it reaches to, so when it becomes to 0, this goes to infinity, it's reaching to infinity. We don't know the value, but we have to show you with the symbol we are reaching to infinity. So if you divide it by a negative value, you reach into negative infinity, and if is a positive value, reach into positive infinity. Right now, look at this f of x. So we can call this f of x equals 2x minus 7. So this is a linear function. So always remember the domain of a linear function is negative infinity and positive infinity. This is the domain values. When we put any values to the x, you get f of x. Say you can put any values to x, 0 to negative infinity and 0 to positive infinity. Any values in between negative infinity and positive infinity, you can keep any values to this x. And also f of x equals x squared plus 3x minus 6. So in this one also, x could be any values in between negative infinity to positive infinity. So the domain would be negative infinity and positive infinity. So remember, any linear function or quadratic functions, the domain could be negative infinity and positive infinity. Now, say this one, we have rational functions like 5 divided by x minus 6. Right? So you know any number dividing by 0, it goes to infinity, right? And then, so if I substitute 6 for x, and this part going to be 0. So I have to say that x minus 6 not equals to 0 and x not equals to 6, because negative 6 you send it to other side and becomes positive 6. So if I mark this value on the number line, number 6 here, and then not equal to 6, without 6 you can, x can be any values. So say the domain would be negative infinity to positive 6 and union 6 to positive infinity. Why I didn't use that square bracket? Because 6 is not included, right? Good. So let me show you another example. F of x equals 2x plus 3 divided by x minus 5. So you know, in this rational function, x minus 5 not equals to 0, and then x not equal to positive 5. So on the top, x could be any value. And so if I mark this one on the number line 5, and then x excluding x 5, and then to here till negative infinity and positive infinity, so I can write down this as domain negative infinity till positive 5 and union 5 and positive infinity, right? So look at this one, number 3. G of x equals x squared minus 4 and x squared minus 9. So you know the top part is difference of two squares, and then I can write down as x minus 2x. So let me simplify further first. X squared 4 I can write down as 2 to the power 2, and then x squared 3 and 9 I can represent as 3 to the power 2. So I can write this on the top, x minus 2 and x plus 2, and divided by x minus 3 and then x plus 3, right? And then we know that the top is fine. On the bottom we can't use here this x minus 3 not equal to 0 and x positive 3 not equal to 0, because x, so you send this minus 3 to this side, then x equals plus 3 and x not equals to plus 3 and x not equals to negative 3. So this one I can write as, if you write drawing a number line on the number line here negative 3 and then here positive 3. So this x could be this up to negative infinity till negative 3, and then in between this area excluding negative 3 and positive 3. So x could be any values in between negative infinity till negative 3 union negative 3 positive 3 union 3 till positive infinity. So this is the domain. Look at this example. So h of x equals 5 divided by x squared plus x negative 6. So in this example you need to factor the quadratic equation. This we need to factorize this x squared plus 6 negative 6. So look at this. If you write down here x squared plus x negative 6, and 1 into negative 6 is negative 6, and then what are the factors of negative 6 is 2 times 3. When you add those two factors you should get that x coefficient, and when you multiply you should get that constant. So this should be negative and 3 should be positive. So x squared plus 3x negative 2x negative 6, put the bracket on, and the common value is x plus 3, and in these two terms, and the common value is negative 2, x positive 3. So x positive 3, and you can combine these two values, x minus 2, right? And then these two values shouldn't be 0. So I can say that x plus 3 not equal to 0, and then x not equals to negative 3, and x minus 2 not equal to 0. X shouldn't be positive 2. So I can write down h of x equals 5 over x plus 3 and then x minus 2. So here I can draw the number line is negative 3 and then positive 2, and then so this range is a one range, here is the one range, this is the one range. So I can say that the domain is negative infinity till negative 3 union negative 3 to union 2 till infinity. So this is the final answer. Right, so I have another example. So you can write this, and f of x equals within square root and then x squared minus 9, and then on the bottom we have x minus 4 and then square root 5 minus x minus 1, and then x squared minus 7x plus 12. Feel free to pause this video and try yourself while I'm doing this. Okay, So you know that the value inside the square root shouldn't be minus. This we're not going to find the square root value of negative values. We're not going to find it. So therefore, x squared, this radicand is x squared minus, so the radicand is x squared minus 9 should be greater than or equal 0. This is one of the conditions. So let me simplify this. So this is difference of two squares. You can write down as x squared minus 3 to the power 2 greater than or equal 0, and x minus 3 and x plus 3 greater than or equal 0. If x value is greater than 3 and this value is positive and this value is positive, and plus into plus is plus, so therefore the x value should be greater than or equal positive 3 is one of the conditions. Now imagine like this. If I take a value less than 3 here, say if I use 2 here, so if I use 2 here, this value going to be negative, and then this is positive. So negative into positive is negative. So x cannot be less than 3. X cannot be less than 3. So therefore x cannot be less than 3, and then only x should be greater than or equals positive 3. So this is 1, and here this is a rational expression, and then x minus 4, right, x minus 4 shouldn't equal to 0. So in this case, so I can send negative 4 into this side, and x becomes, or x not equal to 4. So if this becomes 4, x becomes 4, and this side going to be 0, and then any value divided by 0 is going to be infinity. So therefore x shouldn't be equal to 4. So this is one of the conditions. Also look at this one. In this radicand, in this place, 5 minus x is 5 minus x inside the square root. So this one should be greater than or equals to 0. And if positive 5 send it to this side, is negative 6 x greater than or equals negative 5. And if you divide it by negative 1 both sides, and then this value changing, this symbol changing to other side, x less than or equals to positive 5. So if you put 5 here, yes, and then this is 0, square root of 0 is 0, but here negative 1's here. But if you put 6 here, it becomes negative 1 square root, and then we're not going to find that square root value of the negative values, so it can't be. And then we have to use that any values less than 5. So look at that. If I use 4 here, 5 take away 4 is 1, square root of 1 is 1, and then let me check. If you use 4 here, yeah, so we can't use 4 here. So if you use 4 here and 5 take away 4, and then is 1, square root of 1 is 1, 1 take away 1 is 0. So we can use 4 here even. So right, so if you use 3, 5 take away 3 is 2, square root of 2, 1.4 something, and take away 1, still we get the positive value. We can do that. And we say negative value. So if we use negative 1, this becomes positive, right? It's fine. So x should be less than or equals 5, but shouldn't be equal to 4. This also one of the conditions, right? So now this part, we have quadratic function equation, the expression, and then we need to solve this one. So look at this, x squared minus 7x plus 12. So we need to factorize this one. So 1 is the x squared coefficient, and into positive 12, which is positive 12. What are the factors of positive 12? Is 4 times 3. When you add these factors, you should get that minus 7, and when you multiply, you should get that positive 12. To get that, the both values should be negative. And x squared minus 4x minus 3x positive 12, put the bracket on, and x is the common values, and then x out, and then minus 4 minus 3 out, and x minus 4. And here, if you combine those two values, x minus 4 and then x minus 3, look at that. And then, so these two values shouldn't be equals to 0. So x shouldn't be equal to 4, and then x shouldn't equal to 3 as well, right? Now, all these values I can represent on the number line. Let me do that. So this is one of the conditions, and so here, also here, if I use the value less than 3, negative 3, say for example, if I use negative 4, this going to be negative, and then this going to be negative, and negative into negative also positive. So this is one of the conditions, and then x value should be less than or equals negative 3, right? And then, so if you use negative 3, it becomes 0, but if you use negative 4, this part going to be negative, and this part also negative. Negative into negative is positive. So these are the conditions. We have x greater than or equals positive 3, and x less than or equals negative 3, and x not equals to 4, x not equals less than or equals 5, and then here x not equals to 4, and then x not equals to 3. So let me draw on the number line all these conditions. So here 0, not, actually we don't need 0 here, and then see all the values. We have negative 3, 4, positive 3, and 4 and 5. So here is x value is less than or equals negative 3, and we can represent here like this. So here negative infinity, so it goes up to here, and then including negative 3. So again, any values bit not equals to 4 and 3, and then so 3, and so any values over 3. Okay, so we don't have any values in between negative 3 and positive 3, and then we can say that we have values less not equals to, so any values, look at that, 3 and say 0. If you put 0 here, 0, negative, positive. Okay, so we don't have that value, right? We don't have that value, the positive, right? Any values less than 3, yeah. 2, if you put 2 here, right, if you put 3 here, so we can use any values between 3 and 4, but excluding 3 and 4. Also, any values x is less than or equals to 5, including 5, right? And then we have all the values here excluding 5, right? So here I can draw this as like this. So we have values negative infinity till negative 3, and positive 3, and in between positive 3 and positive 4, but excluding those two values 3 and 4, and any values less than positive 5 including 5. So I can write down all the domain as D, negative infinity till negative 3. So negative 3 is included. Yeah, negative 3 is included, right, negative 3 including negative 3 union 3 till 4, excluding 3 and 4, union 4 and including 5. So this is the final answer, all the domain, the x value for x. Thank you very much for watching this video. We can join with next video. Thank you.